Ms. Deepa from St. Josephs College of Arts and Science for also assistant professor in Department of Mathematics. In this video, we will see what is limits. First one is the class L square. The class L square is the class of all sequences S, that is Sn n equal to 1 to infinity such that summation n equal to 1 to infinity Sn square less than infinity, summation n equal to 1 to infinity Sn square less than infinity, summation n equal to 1 to infinity Sn square is a finite number. Any element of L square is in sequences. Some element of the class L square, the constant sequences is equal to 0, 0, 0 for summation Sn square equal to 0 plus 0 plus 0 equal to 0, that is finite. 1 by n equal to 1 to infinity as an element of L square. Here Sn equal to 1 by n, Sn square equal to 1 by n square. Summation Sn square equal to summation n equal to 1 to infinity 1 by n square is convergent. The next one is limit of the function on the real line. Let f be a real valued function and a belongs to R. Then we say that f of x approaches to L as x tends to a. If given epsilon greater than 0, there exists delta greater than 0 such that modulus of f of x minus L less than epsilon, where modulus of x minus a lies between 0 to delta. In this case, we write limit extends to a f of x equal to L, or f of x approaches to L as extends to a. Next one is right hand limit. We say that f of x approaches to L as x approaches a from the right if given epsilon greater than or equal to 0 and delta greater than or equal to 0 such that modulus of f of x minus L less than epsilon, that implies limit extends to a plus f of x equal to L. Hence L is called the right hand limit of f at a. Next one is left hand limit. We say that f of x approaches to L as x approaches A from the left if given epsilon greater than or equal to 0 and delta greater than or equal to 0 such that modulus of f of x minus L less than epsilon, that implies limit extends to A minus f of x equal to L. Here L is called the left hand limit of f at A. Next one is definition of non-increasing function, non-decreasing function, and monotone function. First one is non-decreasing function. Definition of non-decreasing function. If f is a real valued function on an interval j, j subset are equal to R, we say that f is non-decreasing if f of x less than or equal to f of y, x less than y, x comma y belongs to j. Next, non-increasing function. If f is a real valued function on an interval j subset of R, we say that f is non-increasing on j if f of x greater than or equal to f of y for all x comma y belongs to j. Last, monotone function. We say that f is monotone if f is either non-increasing or non-decreasing. Definition of strictly increasing function and strictly decreasing function. First one, strictly increasing function. The real value function f on the interval j subset of R, then f is said to be strictly increasing if f of x less than f of y, x less than y, for all x comma y belongs to j. And upon strictly increasing function, the real value function f on the interval j subset of R, then f is said to strictly decreasing if f of x greater than f of y, x greater than y, x comma y belongs to j. The last one is metric space. Let M be any set. A metric for M is a function rho with domain M by M and range contained in close interval 0, open interval infinity such that rho of x comma x equal to 0 for all x belongs to M, rho of x comma y greater than 0, x comma y belongs to M, rho of x comma y equal to row of y comma x comma y belongs to M. Last one, row of x comma z less than or equal to row of x comma y plus row of y comma z. For all x comma y comma z belongs to M, a row is called metric for M and it is called distance function, and M comma R is called metric space. Thank you.